Hey mathematicians, here are your notes for 13.1, day 2. We're still working on the introduction to trigonometry. So for our bell work, we want to refer to the triangle at right, and we want to match each trigonometric function with the correct ratio. So again, this is why we're specific about which angle we're talking about, in this case theta, because the angle tells us which ratios we're looking at. So if I want sine of theta, I'm going to take opposite over hypotenuse, which is s over t. I'm going to go through and find that. That's IV. And there's our first one. Tangent would be opposite over adjacent, so s over r, v. Secant, that is my reciprocal function of cosine, meaning instead of adjacent over hypotenuse, I'm going to take hypotenuse over adjacent. So hypotenuse is t over adjacent, which is r. So t over r would be my 3 i's there. Yes, I like to make the i's a little bit curvy. And then cotangent is the reciprocal function of tangent. So instead of opposite over adjacent, we're going to have adjacent over opposite, or r over s, 2 i's. Cosine is ca, that is the a over h, or adjacent over hypotenuse, meaning r over t. That's our first little I. And then cosecant, our reciprocal of sine. So instead of opposite over hypotenuse, we're going to do hypotenuse over opposite, t over s. And we have accounted for all of our options. So now that we know how to set up the basic trig functions, we're actually going to start using them to figure out both missing sides and missing angles. So here's our first couple of examples. We want to start by writing an equation involving sine, cosine, or tangent. We don't want to use those reciprocals if we don't have to. And then we're just going to solve the equation. So I notice this triangle, I'm given 2 sides and an angle. Specifically, I'm given the opposite side and I'm given the adjacent side. So this would be a ratio that would use tangent. However, I'm not working with theta this time, I'm working with 38 degrees. So if I want to write this out, I would say that the tangent of 38 degrees is equal to the opposite over the adjacent, which is x. Now that I have this, I can go ahead and solve. And I'm going to solve for x the same way I would as if this whole concept was just a number. We multiply both sides by x to get rid of that fraction. I want to get x alone, so I divide by tangent of 38. So I get 10 divided by the tangent of 38. And you're going, Miss Burry, I don't know what the tangent of 38 is. Well, how fortunate for you that your calculator does. So if you have one of these little scientific calculators, the first thing I want you to check is that this bottom piece, this bottom word here says DEG. If it doesn't, you're going to have to hit settings, this DRG, and you'll have degrees, radians, or GRD. We don't use GRD. We really only use degree and radians. So make sure it's in degrees for right now. There's a way to do that on your graphing calculators as well. If you're interested, come see me. Once we have it in the right mode, we're just going to plug it in. 10 divided by the tangent, notice you've got sine, cosine, and tangent right there, of 38 degrees. I close my parenthesis, and I have 12.79, yada, yada, yada. But again, it says to the nearest tenth, so I'm going to go 12.8. So in this case, x equals 12.8. And it doesn't give me a unit, so I'm not going to put one on there. The next triangle, again, not theta, 63 degrees, gives me the adjacent side and the hypotenuse. I know that my trigonometric function that uses adjacent and hypotenuse is cosine, so I say cosine of 63 degrees is equal to adjacent over hypotenuse. If you saw the trick that happened here, you'll notice your x and your tangent just switched places. So when we solve for x in something that is set up like this, we can just say x is equal to 4 divided by the cosine of 63. We don't have to do all that solving each time. It's a trick that works. Same thing, throw it in the calculator. 4 divided by the cosine of 63 is 8.8. So in this case, x equals 8.8. All right, go ahead and try that last one on your own. This one A little bit different, but see if you can at least set up the ratio. All right, if you gave this one a shot, should be able to set up a ratio because we notice we have the adjacent side and the hypotenuse, meaning this is another cosine. So cosine, unfortunately, of x is equal to adjacent over hypotenuse, so 5/8. However, even though we have a number over here, that's what cosine is equal to, not x itself. So what we're going to do is we're going to take the inverse of cosine, and that is also on your calculator. It's just right above in yellow, or in, I guess maybe in a different color depending on what color your calculator is. So we're going to type this into our calculator as cosine to the negative. Oh, I should have put, this should have been 5/8. My apologies. Equals x. So all we've done is we've switched those and flipped our cosine of -1. So if I've got a fraction on one side and I need to solve for what's inside, I can flip that fraction and solve for x, which in this case is that missing angle theta. So I get x equals 51.3. And this one I do have to label because it's an angle measure. So I label it with the degree symbol. So this is the really important part today. To solve a triangle means to find, and I'm going to put this in all caps, all sides and angles. It doesn't just mean the one that's labeled X or Y, it means all of them. Let's go ahead and flip this over. So when we are solving triangles, we're going to want to solve for all sides. However, in word problems, it may specify what it wants you to look for. So be careful to read those directions. So some applications of trig use an angle of elevation or depression. In the figure at right, the angle formed by the line of sight, this is really important, line of sight from the observer and a line parallel to the ground. There's your line of sight up, and there's your line parallel to the ground. This is your angle of elevation. Obviously, elevation goes up. The angle formed by the line of sight from the plane and the line parallel to the ground. So up here is your angle of depression. Depression meaning downward. So your line of sight doesn't change, but where your angle of elevation or depression are due based on that line parallel to ground. All right, enough of that. A 150-foot rope is tied from the top of a 100-foot tall pole to a stake in the ground. What is the angle between the rope and the ground? Well, let's just start with drawing a picture. 150-foot rope is tied from the top. All right, there's our rope. 100-foot pole, there's the pole. It says, what is the angle between the rope and the ground? So if this is my ground, I'm assuming that it wants this angle and not this 90-degree angle, because this is the rope and the ground and the angle made between them. Since I don't have that, I'm going to go ahead and label it X. Now I'm just going to set up another trigonometric ratio the way I was doing on the page previous. I have opposite, I have hypotenuse, so that would be a sine. Sine of x is equal to opposite over hypotenuse. Again, this is one where I'm going to have to use that secondary button on my calculator. I can go ahead and solve this by taking sine inverse 100 divided by 150 equals x. Use the button on my calculator. And I get 41.8 degrees. Just like that. Go ahead and see if you can set up the ratio for the next example. All right, hopefully you tried that one on your own. Let's try it together. A car is traveling 750 meters along a ramp raised 4 degrees. Okay, so here's our ramp. 750 meters. It's 4 degrees from the ground. So here's our ground, here's our 4 degrees. That seems pretty extreme angle. Not drawn to scale. All of my drawings should have that disclaimer. How far did it rise vertically during its trip? So this would be our vertical distance that we don't know, meaning x. So based on this angle, the two sides that I technically am working with are opposite and hypotenuse again, so it's another sine. However, this time I do have an angle measure to plug in. I have sine of 4 degrees, which is equal to x over 750. To solve this one and get x by itself, I'm just going to multiply both sides by 750. So I'm going to say sine of 4 degrees times 750 is equal to 52.3, meaning his vertical change was 52.3 meters because that's the original label we were in. And last one. Trevor is standing on top of a cliff 200 feet above a lake. All right, there's your cliff, 200 feet. It'd be nice if you could see it, I suppose. There you go. The measurement of the angle of depression to a boat on the lake is 21 degrees. So I'm going to go ahead and do my angle of depression to a boat. So this is his line of sight to some boat over here. Notice my angle of depression is not the line of sight to the vertical cliff. It's from the line parallel to the ground down to his line of sight, meaning this angle is 21 degrees. How far is the boat from the base of the cliff to the nearest foot? So he wants to know this distance right here. All right, so this one's a little tricky because we don't technically have either of our theta angles that would be helpful. We have our right angle, but we don't have these two. Fortunately, that angle of depression, if we assume this cliff makes a 90-degree angle with that line parallel to the ground, I don't know why your cliff would be at an angle, so it should be straight up and down. We can find that inner angle by just subtracting and finding 69 degrees. Once I have this inner theta to work with, I notice I have the opposite side and the adjacent side, which I can then put into a ratio of tangent of 69 degrees equal to opposite over adjacent, and then of course multiply both sides by 200. 200 times the tangent of 69 degrees is 521.0. And it says to the nearest foot, so 521 feet away. All right, this has been day 2 of your introduction to trig. Let me know if you have any questions.